All right, we're still in section 3.5. This is the fourth and final video in this section. If you'll go all the way down, we're going to be talking about graphing techniques. We want to graph our rational functions. So I've got some steps here for you to help you out. It is good to work through these steps as many times as you need to so that you'll remember it on your test without actually looking at the list. So you'll notice that we have this rational function. P and Q are polynomials. And so in order to graph, the very first thing that you want to do is factor. If at all possible, factor both the numerator and the denominator. The second thing that you're going to want to do is find any vertical asymptotes. You remember you do that by looking at whatever makes the bottom zero. Thirdly, you want to find any horizontal asymptotes. The way that you do that, remember, is to look at the degrees. Which degree is higher, the one on top, the one on bottom, or are they equal to each other? For step 4, we want to find Y-intercepts. Now you remember that a Y-intercept is found by plugging in 0 for all the x's. And that's exactly what's happening here. We want to plug in 0 for all the x's and just solve. And this will give us our Y-intercept. For step number 5, we want to find the x-intercepts. And we're going to do this by only getting f of x equals 0. And this is going to be done by only looking at the numerator. If you can find the zeros of the numerator, if you can find out what makes the top 0, then you will be able to find the zeros of the rational function. So once again, vertical asymptotes, what makes the bottom 0? X-intercepts, what makes the top 0? Horizontal asymptotes, look at the degrees. For Y-intercepts, make all your x's equal to 0. Okay, so hopefully these little shortcut concepts will help you to remember these. And then lastly, we're going to draw all steps 1 through 5 on our, technically steps 2 through 5 on our graph. Once we have all of these things on our graph, then we're going to go to the graphing calculator and we're going to graph on the calculator and just get the curvy pieces of the graph. All right, so example number 5. Let's start with this. And we have, first thing that we want to do is to factor. The top doesn't need to be factored, but the bottom does. So my horizontal asymptotes, I have 2 of these. So it's going to be a x equals -2 and a x equals 3. So the very first thing I'll do then is I will go put these on the graph. So x equals 3 and at x equals -2. And then my horizontal asymptotes, I'm going to look at the degrees. I like to look at the original for this. So you'll notice the top degree is less than the bottom degree. So this tells me that my horizontal asymptote will occur at y equals 0. So we'll put this on the graph as well. My Y-intercept is going to occur whenever I plug in 0 for all my x's. So I plugged in 0 for all my x's, and I used the factored version to do that. And then when I simplified, I'm going to get 1/3. So my Y-intercept is going to occur at 0, 1/3. Now I know that this is really tiny. You gotta, whoops, I erased it. You got to get that in there, but 0, 1/3. And then lastly, for my x-intercepts, I'm only going to take a look at what makes the top 0. Well, the top is x minus 2. So when I solve that, I'm going to get an x value of 2. So my x-intercept is going to be at 2, 0. Now you remember a few minutes ago, I told you that you can cross over, you can touch a horizontal asymptote. And we see here that my x-intercept lands on my horizontal asymptote. All right, so now we're going to head over to my graphing calculator. So if we'll pull that up. Sorry, I don't have mine pulled up. There we go. I'll get both screens on here at the same time. Go into your y equals. Now, the word to the y's here, and this is what a lot of students tend to forget, is that the entire numerator needs a set of parentheses and the entire denominator needs a set of parentheses. Now, I tend to always go back and graph the original just in case I messed up on my factoring. This is a way to catch some of your mistakes. So the top is going to be x minus 2. and the bottom is going to be x squared minus x minus 6. Now remember, the only purpose of this next step is just to get the curvy pieces of the graph. We have a lot of important stuff on the graph. We just want the curvy pieces. Okay. And so one of the things that your calculator is not going to show you is going to be those asymptotes. We already drew them, so we know where they are on the graph. So let's split the graph up into the left side of my first asymptote, then the middle between the two asymptotes, and then lastly the right side of my asymptote. So those are the three sections I'm going to look at. When I look at this section and compare it to my graphing calculator, I can see that I have this curvy part, and it looks a lot like the shape of my parents in an earlier video. Remember that you use your asymptotes as fences. All right, the middle piece, notice that on the left side of the asymptote, I'm getting closer and closer to the top. But on the right asymptote, I'm getting closer and closer to the bottom. And I have 2 points there to hit along the way. And then last but not least, mine doesn't completely show up all the way. But I've got my, again, it kind of looks like the shape of those parents. And that's what it looks like. All right, let's go to example number 5. I'll leave my calculator out there. So in example number 5, once again, we want to factor if possible. My vertical asymptote is going to occur at x equals -1. My horizontal asymptote comes from degrees. The 2 degrees are the same. And so leading coefficient on top, leading coefficient on bottom is going to give me y equals 4. My y-intercept occurs when I plug 0 in for x. And this is going to give me the value of -2. So my y-intercept then is going to occur at 0, -2. And then my x-intercept, whatever makes the top 0. So when I look at that, it's whatever makes 4x minus 2 equal to 0. So when I solve that little equation, I'll get x equals 1/2. So my x-intercept is going to be, 1/2 0. All right, so now what I'm ready to do is go over to the calculator. So you want to go back to your y equals, clear out what's there. And again, make sure that you put parentheses around the entire numerator and the entire denominator. So we have 4x minus 2 divided by x plus 1. And you can go ahead and graph. All right, so we kind of know then what the shape is. Going back to our graph, it's pretty easy to see how it's split up. So on the left side of that asymptote, that vertical asymptote, we're up in the upper quadrant. And so my graph is going to have that parent shape again. And on the right side, it's in the lower right quadrant, but I do have 2 points that I need to get through. Okay, example number 7. So once again, when you're dealing with example number 7, the first thing you want to do is factor as far as you can. But what I noticed on this one is that the bottom is factorable. The top cannot be factored. So I only factored the denominator. So I have a vertical asymptote. It's going to be at x equals -3. Notice that there is a duplicate there. It's x plus 3, that factor squared. On bottom, there is a multiplicity of 2. And I'll be talking about what that does in our graph here in just a moment. And so horizontal asymptotes, notice that the degrees are the same. So it's going to be leading coefficient over leading coefficient. So y equals 2. My y-intercept, plug in 0 for x, and you're going to get negative 4/9. All right, so folks, negative 4/9 is basically a little less than a negative half. So I'm just going to go ahead and put close to a negative half there. And then for my x-intercepts, since the top was not factorable, the only way I can solve that quadratic is one of my other methods. So I just chose to use the quadratic formula on this. And so there's the work that I have. But since I'm graphing, I just went ahead and got some decimal values for that quadratic so that I could put them on my picture. So 0.85 is really close here to 1, and the other one was negative 2.35. So that's going to be in here somewhere. So it's going to look a little weird, just to let you know. All right, so I have everything on my graph that I can possibly get on my graph. So the next thing I'm going to do is go to my calculator, and let's put it into the calculator. Again, I like to use the original for that. So go to your y equals screen, clear out what's there. I'm going to have 2x squared plus 3x minus 4. Close up your parentheses. Divide x squared plus 6x plus 9. All right, and you can go ahead to the graph. And the first thing I notice is that my window is not large enough to be able to see exactly what's happening. I just want to check this really quickly to make sure that I have, aha, I started to say, something is wrong with this. It looks more like a polynomial. Do you see what I missed? Hopefully you noticed it as I was typing. My division sign there, I thought I pushed it, but somehow it didn't get in there. All right, so now let's look at their graph again. Okay, so my window still isn't fantastic, but at least now my window is matching more of what I have on this screen. So notice that if I'm looking at this side of the vertical asymptote, it looks like I'm up in the upper left quadrant, and it looks like a parent curve. Okay. And then when I look at the right side of that vertical asymptote, this is where it gets a little wonky. So just look at it little piece at a time. Look at the 2 x-intercepts and the 1 y-intercept that you have. We have them all marked on our graph, so we need to make sure that we hit that. Notice also that right next to the asymptote, it looks as though it's going up to a positive infinity. And so from that point, I'm going to come down and hit my first x-intercept. And then I'm going to come down further. I don't really care how far down you come, but we're going to come back up and hit the y-intercept. And then we're going to hit the x-intercept. But then this is where I need to see more of my graph. So let's enlarge this again. Remember that you want to use your fences, okay? So I'm supposed to be getting closer and closer and closer to that y horizontal line of 2. So if you feel the need, you can take your window for the y maximum. Let's take it all the way out to, oh, I don't know. Let's just try 50 and go back to the graph. And it does appear that way out on the end, it's getting closer and closer and closer to that horizontal line of 2. Okay, so that one's kind of a little bit funky. We haven't seen one like that. Notice, though, that I did cross over the horizontal asymptote. I did that in example 7, and I also did that in example 5, but you'll never cross over a vertical asymptote. Now, I mentioned that this one had a multiplicity of 2 on bottom, and so I want to talk about how does that affect the graph. So if when you're looking at multiplicities just in the denominator, if you have an even multiplicity, then you're going to have two on either side of the asymptote. They're going to be going in the same direction. So let's take a look here. Notice that I had a multiplicity of 2, which is even, and both of these parts of the curve on either side of the vertical asymptote both went up to positive infinity. That did not happen here. Notice here, one side's going up to the top and one side's going down to the bottom. It didn't happen here. Here we've got a bottom and a top on either side. And then on this one, we've got a bottom and a top. So, and I had multiplicities of 1 on this one. Same here, it was a multiplicity of 1. So when I have that even multiplicity, notice that they're gonna go the same direction on both sides of the vertical asymptote. If my multiplicity is odd, they're gonna go in opposite directions. So you can think odd is opposite. Just a real quick reflect question. How do we find vertical asymptotes? This is where we find out what makes the bottom 0. How do we find horizontal asymptotes? We decide these by using degrees. All right, the last thing that I want to talk about in this section is having a hole in the graph. We haven't dealt with that yet, so I want to walk you through how do you deal with a hole in the graph. So we're going to follow the same steps that we've been following. The first thing is that we need to factor as far as we can possibly factor. So the top factors, the bottom is not needing to be factored. But one of the things that I hope you'll notice right away is that I have a pair of identical factors that can be canceled. These two are identical. They can be canceled. And so the only thing that I have left, my simplified function, is now x plus 2. Okay, so if I have identical factors on top and bottom are going to cause a hole in the graph. And so in this case, the hole is going to occur at the x value of 3. The hole is going to occur at the x value of 3. All right, so what I'm going to do is, as I already did, I canceled my identical factors. And then I'm going to take that x equals 3 and I'm going to plug it into my new function. Okay, so we're going to find, in this case, f of 3. So take that 3, the number that caused the hole, plug it in to the new function, the reduced version of the function. Okay, so f of 3 is equal to 5. So that means that the hole in our graph occurs at the coordinate 3, 5. So let's go draw that on our graph. The coordinate 3, 5. And instead of just drawing a point, I'm going to draw an open circle, showing that I have a hole there. All right, my vertical asymptote in this case, okay, here's the deal. Don't say that your vertical asymptote is going to occur at x equals 3 because x equals 3 already caused a hole in the graph. So it can only have one job or another. It can cause a hole or it can cause a vertical asymptote, but it can't cause the same thing at the same time. So in this case, because my reduced version has nothing on bottom, then I have no vertical asymptotes. And then if you look at the degrees in the original function, degree on top is higher, so there's not going to be any horizontal asymptotes. And so basically what I need to draw now is f of x is equal to x plus 2. And I don't even need a calculator to do this. This is a line. It's the identity line just shifted up 2 units. So all I'm going to do then is just draw the rest of my line. There's that on that side of the hole, and then this side of the hole. So it's the same thing as your regular line, except that it has a hole in the graph. And for the record, if you do go and you graph what you see here in your calculator, the hole is going to be so tiny that you're actually not even going to be able to see it. So then what causes a graph to have a hole in it? What you're looking for is going to be identical factors on top and bottom that can be canceled.